Hi, my name is Reza Rokui. I'm PLM at Nokia. I'm responsible for carrier SDN solution for 5G network slicing. In today's talk, we are going to talk about the 5G network slicing and how the carrier SDN solution can be used for automation, assurance, and optimization of transfer slices. Network slice is an end-to-end concept. As is shown here, the operator Y has 3 customers, BMW, Fiat, and public safety, and each one needs the multiple end-to-end individual, the independent logical networks. Each of these networks are called network slices. The color represents the SLA requirement for each of them. In this example, operator Y created 5 network slices. It contains RAN slice. Each of the network slices contains RAN slice, which is a context in a RAN, core slice, which is a context and personality in core, and transfer slices, which are the connectivity between RAN and core. Each individual domain has a controller, RAN controller, core controller, transfer controller, and we have an end-to-end orchestrator. Let's get back to the network and see how, for example, the green infotainment slice is created in this network. The logical flow is, I have a customer, Honda, who needs an end-to-end network slice for infotainment, and the budget for SLA is 10 megabit per second. Customer portal sends a request to operator, and operator uses its network slice blueprints or templates to generate network slice profile. And after that, it goes through various decomposition and triggering various action in the network. The first thing it does, it sends a request to NFVO, which is creating the virtual RAN, virtual core, or both if it's needed. The second portion is it sends a request to RAN controller to create RAN slice, give the personality to RAN equipment. By the same token, it sends a request to 5G core controller to create the core slice, which is a personality in the core. And last but not least, it sends a request to transfer slice controller to create the connectivity between this RAN and core. At this point, stitching all these slices creates a single end-to-end network slice for a specific customer, which is Honda and service type that is explained before. The role of carrier SDN solution from Nokia is to control for the transfer slice as is shown in this picture. Interface 4 and 5 are defined in 3GPP, and interface 6 that is not defined in any SDOs yet, and Nokia is working towards to make that one a standard as well. This is a network that I'm going to use for a portion of the demo. I have a transport network which is connecting RAN to core. NSP as a transfer slice controller used for 3 different use cases: automation of transfer slices, monitoring of the transfer slices, and optimization. In the demo, I just showed the optimization, but these are the 3 important use cases that should be addressed by any transfer slice controller. During the demo, NSP receives various connectivity APIs from the northbound. During the demo, Postman is simulating those APIs. Transfer slice controller intelligently receives that message and creates services, tunnel, and LSPs, which is needed in the network. Let's get back to the demo. This is NSP Launchpad, service fulfillment, and IP MPLS optimization and service supervision application are used in the concept of transfer slices. The first transfer slice is created for the Honda infotainment. The service time and NSSI is 10 and 20. And we showed the optimization, how NSP is used for the monitoring of the transfer slices. When we inject the latency of 20 milliseconds for IGP link, we will see the latency is changed, and we will see momentarily that reroute happen in the network. In other words, NSP intelligently monitor transfer slices, and we do the reroute. If I put the latency back to 2 milliseconds again, nothing will happen because in this case, the path is still valid unless I go to the reroute, and after reroute, we will see that the NSP again brings back the original path of the LSP. In summary, carrier extend solution from Nokia is addressing the 5G transfer slice in 3 important areas: automation or creation of the transfer slices, assurance or monitoring of transfer slices, and closed loop optimization. These are the 3 main important aspects that should be addressed with any transfer slice controller. Thank you for your attention, and hopefully I see you later.